All right, welcome to lesson 7. I'm learning to use density to identify a material is our current topic. We can see here interesting recreation of our little pen cap experiment, but with a few more things going on. I think it's pretty interesting to see this. So we're going to talk about what density is with more detail, the vocabulary, the definition, and symbols and units. Okay, and then the formula. And last, about flotation or buoyancy, which we're kind of seeing on display here on the screen for us. All right, so the first thing, vocabulary. Mass. That's how much matter, how much stuff there is. We easily calculate mass on Earth using weight. Now, volume is how much space an object occupies or takes up. Volume is length multiplied by height, multiplied by width, or depth. We use these interchangeably depending on how we're thinking about the object. Now, to define density, the compactness of a substance, sometimes called volumetric mass, is the real fancy definition. But the simple version is how many atoms is in the box that you're looking at, and therefore how much mass that box has compared to how big it is, its volume. Okay? And so if we look at an example, imagine you're on a bus that you're riding, like the one in our picture here, that's full of people, just stuffed full of people. You're getting elbows into your body all the time. There's just tons of people in there. It has more mass. There's more people inside, right? And so it weighs more than later in the evening when that same bus doing the same route and there's like 3 people on there, right? That is the same bus. It has the same volume. It has the same amount of space that it occupies, that it takes up, like it was on the curb. But how much it weighs, its mass, has changed. So, in science, instead of using a bus as our box, buses are kind of big, I can't really hold a bus, we use a cubic centimeter. And here's a picture of a bunch of little cubic centimeters, or centimeter-sized cubes, as you can see in the bottom left of our screen here. It is a cube that is 1 centimeter on each side. That's why it's a cubic centimeter. And there, again, like I said, that's for reference. Now, when we come to the formula for density is density, capital D, is equivalent to M for mass divided by V for volume. Okay, we show this formula here with the letters because that way we can just refer back to be like, oh, so if I know that this mass, this weight is 17 kilograms or 13 grams, I can just put that where the M is to replace it. And then if I know that the volume is, let's say 50 cubic centimeters, I can put that in for V, and then I can solve for D. Okay? So as I said, D is for density, M is for mass, and V is for volume. So this math triangle represents the relationship between these, like I said. So mass, you can multiply across. You want to find this, multiply density times volume. If you want to find density, this is what you don't know, well, mass divided by volume. Okay, this is how the math triangle really helps us. And if you want to find the volume, well, it's mass divided by density. Okay, that line, the division line here, it's kind of like if you made a fraction. All right, so here, down here again, we've got a way to think about these symbols and units. So we need symbols and units to keep our numbers straight because I don't know if that 13 is supposed to be the mass, the volume, the density, etc., etc., etc. Okay? Mass is in grams. So you see here, mass equals G, always that. However, volume in a solid is a cubic centimeter, cm for centimeter, and then that 3 on top. That's because there's 3 directions, right? Length, width, height. So there's 3 ways we're multiplying by. Okay? Now, remember that 1,000 grams is 1 kilogram, and just for fun, 454 grams is 1 pound. Okay? Now, CM3, like I said, all 3 directions. And this math works because if you divide mass by volume, you're using the math to cut whatever size and shaped object you're thinking about into imaginary cubic centimeters and how much those would weigh. All right. Now, we mentioned grams per cubic centimeter for the solid substance. That's literally how much a 1 centimeter cube of it would weigh if we get a perfect 1 centimeter cube. Density is grams per milliliter for liquids. Now, 1,000 milliliters is 1 liter. You've probably heard of liters. 2 liter is 2 of those liters. And 1 liter is about a quart. And this is roughly 3 cans of soda or 4 cups. A lot of ways to think about this. One thing I think is really interesting about this, by the way, is that 1 gram is 1,000 grams is 1 kilogram. And 1,000 milliliters is 1 liter, which means that 1 kilogram per liter is exactly the same as 1 gram per milliliter. Kind of neat. Okay, this really makes a lot of math and science easier. So, the last thing we're going to talk about today is the buoyancy or flotation of objects, which is from Archimedes' principle. Okay, so that's the ability to float in water or air or other fluids. Things that float have buoyancy relative to whatever fluid they are in. So in a container, like we see here, there's iron, obsidian, rocks, metal. It's sunk all the way to the bottom because objects or even fluids, like we saw in our lab, will sink or float until their density matches the density of the fluid they're in, or until they get to the very bottom of the container or the very top of the container. All right. There's a famous story about Greek philosopher Archimedes involving these principles. You're going to read it in your chem talk. So this is why we call this Archimedes' principle. Okay. Now, water's density is roughly 1 gram per milliliter in normal situations. That's why that works. 1 gram to 1 milliliter, 1 gram to 1 centimeter, and so on. Now, rocks are about 2 to 3 grams, depending on the kind of rock it is. They sink. Wood is about 0.2 to 0.9, which is less than 1. Wood floats. And that is the end of our lesson. Good luck with this one. Hope you guys have a great rest of your day.